Welcome to today's exploration, where we unravel the complex and invisible tapestry of air pollution. It's a narrative of combustion, consequences, and the unseen contaminants that surround us. Coal combustion. It's more than just burning rocks. When coal combusts, it releases a cocktail of air pollutants, including carbon dioxide, carbon monoxide, sulfur dioxide, and an array of toxic metals: mercury, lead, arsenic. Even radioactive particulates aren't spared. Among these, mercury stands out. A silent perpetrator causing neurological damage, it doesn't just impact us directly. It bioaccumulates and biomagnifies up the food chain, from tiny plankton to massive whales. And it's primarily released by the burning of coal to create electricity. But the narrative doesn't end with coal. Our dependence on fossil fuels introduces yet another villain: nitrogen oxides. As these gases escape into the atmosphere, they kickstart a chain of events: the production of ozone, the formation of photochemical smog, and conversion to nitric acid. These activities lead to the dreaded acid rain. Meanwhile, sulfur dioxide, another byproduct of the burning of fossil fuels, especially diesel fuels, contributes to deteriorating air quality. In this story, however, there are heroes too. The Clean Air Act, enforced by the Environmental Protection Agency, or the EPA, significantly regulated the use of lead in fuels, dramatically decreasing the amount of lead in the atmosphere. Air pollution isn't a single entity, but a combination of primary and secondary pollutants. Primary pollutants are directly emitted from sources, while secondary pollutants form when primary pollutants react in the environment. Let's dive into one of these secondary pollutants: photochemical smog. It's formed when nitrogen oxides and volatile organic hydrocarbons react with heat and sunlight. The result? A host of pollutants that cloud our skies. Nitrogen oxides plus VOCs plus UV light equals smog. And the problem has rhythm. As the sun rises, nitrogen oxide is produced by vehicles. As the day wears on, ozone concentrations peak in the afternoon and hit even higher notes in the summer. This is because ozone is a product of chemical reactions between oxygen and sunlight. Add in volatile organic compounds, or VOCs, like formaldehyde and gasoline, which evaporate at room temperature, and you have a potent recipe for pollution. Urban areas, with their high concentration of motor vehicles, often become the epicenters for photochemical smog. However, there's hope. By decreasing the emission of nitrogen oxides from vehicles, we can reduce the concentration of ground-level ozone in our cities. However, tackling this issue isn't just about handling nitrogen oxides. Volatile organic compounds, or VOCs, also play a significant role. These compounds, such as formaldehyde and gasoline, evaporate or sublimate at room temperature. Trees, nature's lungs, are also a surprising source of VOCs. So why does this matter? Photochemical smog isn't just an eyesore. It can cause respiratory problems and eye irritation, affecting our health in ways we may not immediately realize. Our journey into air pollution doesn't end here. There's a phenomenon that can exacerbate these issues: thermal inversion. In this event, the normal temperature gradient in the atmosphere flips. The air temperature at the Earth's surface becomes cooler than the air at higher altitudes. This inversion forms a sort of lid, trapping pollution, especially smog and particulates, close to the ground. The air layer closest to the Earth's surface is denser than the layer above it, so it resists circulating, holding these pollutants hostage at ground level. A specific example of this? Smoke from forest fires, which can affect air quality over larger areas for many days, especially when a persistent atmospheric inversion exists. Our journey today has shown us the complexity of air pollution, a challenge that's both unseen and yet surrounds us. It's a battle that's waged not just for us, but for the future of our planet. The challenge may be great, but so too is our ability to make a change.